This program was applied to apply the optimal heat treatment control scenario according to process machine learning by segment vectors. It used to be all of the heat treatment surfaces. At the result, I'm going to show the conclusion. We propose an optimization system through monitoring the temperature rise of heat treatment equipment. Among the process technologies, the heat treatment process and experiment have various site requirements, such as long process time, lack of professional manpower, and monitoring workers, access to hazard areas. It is very tremendous and it is very difficult. In particular, it is practically difficult to proceed with the process design considering the efficient treatment of the heat source through monitoring the internal conditions of the heat treatment. Okay, so it is our benefits. If efficient temperature control according to various heat sources can affect the overall improvement of material properties, the range of application of existing process can be increased. Thank you for listening.
Hello, I am Jinung Lee. I'm going to start presentation now. I will present them in the following order. First, instruction. Second, related research. Third, main subject. Fourth, design. Fifth, conclusion, etc. Current situation. The purpose of personal transportation is to move quickly, conveniently through ambiguous streets that are too close to get to the destination and too far to walk. Problems with existing technologies. It is a risk factor not only for users, but also for pedestrians and road drivers. It is necessary to prepare alternatives. The detailed disease structure is as follows. Suggests a plan to build a demand-responsive shared service for small electric vehicles. First, an overview of small electric vehicle sharing service solution and service definition were analyzed. Second, the configuration of the shared service system was analyzed. Related research is as follows. First, manager system, a system that controls the state and location of the vehicle. Fleet management system, real-time data collection such as driving record by installing OBD2 on the vehicle and real-time control system. And sharing platform, a platform that provides service so that users can freely rent a vehicle at any time through the app. Small electric vehicle sharing service. Integrated application, for example, user app, operator app, or administrator web app. Derivation of requirements for each service, provision scenario section, function development, and user testing, etc. Service function definition. I divided the service function definition into three parts. Sharing platform, smart infrastructure, control system. First, shared platform service includes member registration and license inquiry system, authentication system, payment system, and digital key system. Second, smart infrastructure service includes shared vehicle parking and shared vehicle charging. Third, the control system includes vehicle management, real-time control, driver management, statistical analysis, and dispatch management service. The following is about the development of electric vehicle sharing service software. I divide the service software development definition into three parts. Fleet management monitoring software, vehicle integrated management software, data management software. First, fleet management monitoring software that can collect monitoring data generated during the service demonstration process and operate it efficiently and stably. Second, vehicle integrated management software that can be managed with a single system ranging from simple charging payment to abnormal diagnosis for safe electric vehicle boarding and precise management. Third, data management software provide refined data such as collection, analysis, and processing of data generated through the provision of the small electric vehicle car sharing service. Shared service contents and output. The output from the small electric vehicle sharing service is as follows. Integrated application development, establishment of control system, smart infrastructure construction, electric vehicle sharing service hardware modification, electric vehicle sharing service software development. This is a user perspective service configuration diagram. Users choose when and where to use the electric vehicle through the app. Upon arrival at the pickup location, the users open the door of the electric vehicle through the app. When users finishing using the electric vehicle, go to the return area and pay the usage fee through the app. This is a requirement analysis by scenario section. The service subscription function has requirements for membership registration, license registration, payment card registration, and agreement to terms and conditions. The car dispatch application function include the following functions: rental location selection, and return location selection, usage time selection, vehicle selection, vehicle insurance selection, and rate check. Third, the requirements of the rental service include when the users arrives at the rental location, using the app to check the appearance of the vehicle, check the amount of charge, and operate the digital key. The requirements of the return service are similar to those of the rental service. And when the user arrives at the return location, there is an app to take a picture of the exterior of the vehicle, connect the charger, and pay the usage fee. Service configuration diagram from the service manager's point of view. The manager is configured to analyze the user's reservation status, vehicle dispatch status, vehicle in use, vehicle return status, service monitoring, and data statistical analysis through the data server. The shared service network configuration diagram is shown as in the following figure. It is designed to enable vehicle control and data transmission and reception by installing OBD2 terminal LTE on electric vehicles. The following is vehicle monitoring via data server. Through this system, you can inquire about vehicle management, real-time control, driver management, statistical analysis, and dispatch management at once. Conclusion. It is expected to contribute to the vitalization of smart cities nationwide by activating the small electric vehicle sharing service, an eco-friendly futuristic means of transportation. to provide service for the transportation system of new cities and smart cities, and to acquire, analyze, and standardize data using them. Benefit. A platform that provides service so that users can freely rent a vehicle at any time through the app. Vehicle location control, driving route tracking, vehicle remote control, theft detection and tracking, vehicle maintenance and status monitoring, driver information management, license management, driving history management, driving habit analysis. Thank you for your attention.
Hello, I am President Iiccc. I will present the paper, Image based on intelligent system that supports efficient production management at the manufacturing site. Now, I introduce the table of contents. Introduction, related research, main subject, simulation, conclusion, references. Currently, production process management in the manufacturing industry, demand for artificial intelligence solution increases. Increase the efficiency of MES and the production management efficiency by automatically recognizing the materials in the process based on artificial paper solution. Problem with existing technology, please refer as follow. Let's check relation research. There are 3 areas of related research. Let me explain the concept. Also, please refer to the picture. RFID, a system that provides various services such as positioning, remote processing, management, and exchange of information between objects by tagging objects to be managed and using radio waves to recognize identification information and the surrounding environment information to collect, store, process, and track information about each object. This is RFID applied system basic structure. CNN. The general neural network is a representative model for automatically learning features from data, mimicking how human visual information is processed. Supervised learning. Supervised learning is a type of machine learning that pre-learns the explicit correct answer for input and then predicts the appropriate preset correct answer through pre-trained data when given a new input value. Main subject, system configuration. Please refer to the documentation and pictures. This is overall management system diagram. System flowchart are the difference between an existing form of a system and a proposal system is that if untyped image information is passed to the server, this is a pattern that recreates that image information. Full proof enters the element list and camera recognition for images that fail to enter image information due to operator errors, recognition errors, and new product information. When image information is recorded, the foolproof pattern is passed to the server. The server identified the cause of the error and ensured that it took action that matched the cause. This is proposed system flowchart from as is to be. Flow is allowed not enter deformation and enter information and forward recognition information, previous data existence and execute task. Database design. Each table in the database consists of create image, processing, store, and foolproof. Please refer to the picture of details. Progressing attribute is composed of image data, receive image data, send image data. The foolproof table differs in that it has a receive alert class for receiving notifications from the processing table in a form similar to the create image table. Database classes diagram defined. The classes are created image, processing, store, foolproof. The attributes are image data, receive image data, send image data of processing class. The methods are awake, check image data, send image data, receive image data, supervised learning of processing class. Simulation of AI recognition modeling. Pre-treatment was carried out on the input material shape image and simulation was performed by holdout cross verification method at 72221 for training, testing, and performance verification. Test case. To evaluate the performance of the training model, 4 metrics are used to evaluate the performance of the training. Model used 4 metrics: object recognition count accuracy, object classification accuracy, F1 score, and recognition speed. And to verify the accuracy of image recognition, AI test images are tested for AI that has been supervised using data set. That's the result. The advantages of this proposed AI solution are as an alternative to the issue of reduced ability to determine multi-products, similar type products, and can be determined based on 99.2%. High object recognition count accuracy and 99.8%. Object classification accuracy as shown above, and can derive judgment results due to the fast recognition rate of 11.06 ms per terms.